So last year in Algebra 2, we did super quickly mention odd and even functions. Very quickly we did. But what we said was, if you have a function that looks like this, would that be an odd or an even function? I'll give you a little hint. I know I covered up what that number was.
Is it even?
Oh my gosh, it's even. It's even, yeah. Because that one term's exponent is an even number. So what would this be?
Odd.
Odd. Because that leading term, that first term, that one term's exponent is odd. Now in pre-cal, we go a little bit more in depth and things change a bit when we have more terms like this. So it's not quite as straightforward as we made it sound in Algebra 2. There's a little bit more to it. But it doesn't change if you just have one term like this. The exponent determines whether it's odd or even. So on a graph, if I'm talking about an even function is symmetric with respect to the y-axis. It's symmetric with respect to the y-axis. Now, who can take a guess at what this would mean? If you're looking at the graphs right below 1, 2, or 3, which one of those do you think would be even?
Number one.
Exactly, yes. Symmetric with respect to the y-axis just means it's been reflected. It looks like it's reflected over the y-axis. So this number 1 right here, if I were to fold along the y-axis, oh, everything lines up, meaning this is an even function. Another way you can think about it is if you have the point xy on your graph and it is an even function, symmetric with respect to the y-axis, the point x negative y should also be on your graph. Right? If I was looking here, okay, this point here is 2, wow, I totally screwed those up. I'm so sorry. Negative xy. Jeepers. I totally wrote that down in the previous class wrong. Ugh. Yeah, so this point right here is 2, 0, and also on this graph is the point negative 2, 0. So that's an even function. An odd function instead is symmetric with respect to the origin. So, which one of these graphs do you think looks like it's symmetric with respect to the origin instead?
Two.
I would say 2, right? 2. If you're looking at the origin as like your center of the graph, does everything look reflected in comparison to that origin? Another way you can, I know that symmetric over the origin is a little bit more tricky to conceptualize. So I like to think about the points more for symmetric with origin. If you have the point xy, the point negative x, negative y should also be on your graph. So here I have the point 3, 2. That means that the point negative 3, negative 2 should also be on my graph, which it is. What about that number 3? What do you think that number 3 is?
Neither.
Yeah, good. It's neither. Ooh, I forgot to write. This is an odd function. And this, you are correct. It is neither even nor odd. All right. So that's how you can look at a graph and know if a function is even, odd, or neither. Also, we may ask you to instead look at functions, equations, and tell whether they, nope, still can't sign in when I registered. I wrote down. Okay, we'll have to talk. If you could send me like a screenshot of that, email it to me. Okay, so here we will also ask you to figure out whether they're even, odd, or neither algebraically. Okay, now algebraically, just like we said up here, look, the original, and if we negate the x, it is an even function. So basically that's saying the exact same thing here. If we negate the x, it is equal to the original function. If when we negate the x, it is the function that we come up with is the exact same as the original, then it is an even function. If we negate both the negative x, I'm sorry, if we negate both the x and the y, the entire function, and those are equal, then it is an odd. And I'll show you exactly what I mean. I know that that probably was gibberish to you just now, and that's fine. So first, always easiest, is to check if it's an even function. It's easier to check for if it's even because if you're looking at this statement right here, you're only having to find one new function. This is the original. So you're only having to find one new function, whereas odd, you're having to find two functions. So obviously, it's easier to check for even first. So let's do it. I need to figure out what negating the x does. Or in other words, wherever I see an x in my original function, I substitute in negative x. Like that. Now, I have realized teaching this in previous classes yesterday and today that some of you guys struggle with how to deal with that negative and when you're simplifying here. So what I'm going to do, I'm going to show you one line of algebra that I normally wouldn't write. I'm just showing you exactly what's going on here. That negative is actually a -1, right? It's -1 times x. Whenever you have two things multiplied together and they have an exponent, you can technically split them apart with both having exponents on them. So what this means is I'm squaring both the negative and the x. What happens when I'm squaring -1? Yes, yeah, exactly. It just becomes a +1, meaning it kind of goes away. And all you're left with, oh, I forgot to bring down the -3. All you're left with here is x squared. And that is as simplified as that function can get. So now that it is as simplified as it can get, I need to look. Is my f of -x the exact same thing as my f of x? Is this the same as this?
Yes.
Yes. So what does that mean? What do I say? Yeah. These are the same. So this is an even function. Now, If you're looking at the steps below, that's what it said. It said determine if f of negative x is equal to f of x. If yes, then the function is even. If no, then you have to check to see if it is odd. So clearly it was yes. I do not then need to check if it's odd. It's always one or the other or neither. So if it is even, it can't possibly be odd. I'm done with that problem. Done, done. Now let's try the other one here. F of x is equal to x cubed over 4. First thing I do is check for even by finding out what f of negative x is equal to. So again, what I do is wherever I see an x in my original, I substitute in negative x. And again, I can think of this as both the negative separately being cubed and the x being cubed. So again, this is not something that I would write if I was a student. It's just so that I can show you what's happening here. What is negative 1 cubed? Negative 1 times negative 1 times negative 1. This time it's, I think someone said it, but really quiet. It's now a negative 1, right? Negative 1 times negative 1 is positive 1. Times another negative 1 is negative 1. So my answer here is negative x cubed over 4. So now I need to check, is this the same as this? No. So it means it is not even. So now, come on, erase. No, wrong thing. Oh my God. So now, whatever. So now I need to find this other side of the statement. I need to figure out what negative f of x is equal to. What this means, instead of substituting in a negative x, what this means is I am making the entire original function negative. Now, lucky for us, this example problem only has one term. So really, when I'm making the entire thing negative, I'm just making this one term negative. I'm distributing the negative. I'm distributing the negative just one time. So it becomes negative x cubed over 4. So now, if it's odd, we know f of negative x is equal to negative f of x. So I need to look, is this negative f of x the same thing as what I found for f of negative x? Are those the same?
Yes.
Yeah, so what does that mean for us? What does that mean this function is? If they are equal, f of negative x and negative f of x.
Even.
Not even. Odd. Odd. And that's what it says right there in step 2. Determine if f of negative x is equal to negative f of x. If yes, then the function is odd. If no, so if these hadn't been equal, then this function would have been neither. Any questions so far?
So you check both even and odd. If it's neither, it's just neither.
Exactly. Yep. So if you check even, doesn't work, move on, check odd. doesn't work, then it's neither. I'll do another one, don't worry. I'll do number 1 right below. So again, we follow the exact same process. First, you check for f of negative x, meaning whatever your function is, you're plugging negative x in wherever you see an x. Okay, so now, like I kept saying before, I'm not going to write that extra line of notes, that extra line of algebra. We're just going to think this through. Remembering that when I'm cubing a negative on an x, I'm cubing both the negative and the x. So what is a negative cubed or a negative 1 cubed?
That would be -1.
Exactly. So this ends up being negative 2x cubed. Now the next one, I'm squaring both the negative and the x. So what is negative squared?
1.
So that means that this original sign remains the same, negative 3x squared. What about that third term? What's going to happen there? Yes, 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 yes. Plus 4x. And then I bring down the plus 4. So now is the stopping point. Now is when I check, okay, is this f of negative x the same thing as my original? No. So what does that mean I need to do now?
Check for odd.
Yeah. Oh, I need to, I'm saying yeah. Never mind. Okay. So now I need to check for negative f of x. Meaning I need to make everything in my original function, that entire original, I need to negate everything. So basically, I'm just distributing the negative to every single term. So this becomes negative 2x cubed plus 3x squared plus 4x minus 4. I kind of ran out of room. Okay, so now I need to look. Is what I found for negative f of x the same thing as what I found for f of negative x?
No.
No. So what does that mean I write here?
Either.
Yes. Okay. Are there any questions? So here's the issue. I would want to ask, okay, do you want me to do another example? However, at this moment right now, it's 11:10. We have 20 minutes before the quiz. So thumbs up if you just want to move right into review time, or thumbs down if you want me to do an even or odd example.
Even or odd isn't going to be on the quiz.
It's not going to be on the quiz. Yeah. Okay, all right. So If you do have more questions about even or odd, I will post my teacher notes on Schoology with the rest of these examples filled in. So if you are still struggling, you can look there. I'm gonna pause this recording.